Hi friend, myself Gandhar Kumar. I am taking electrical machines for mechanical engineering students. We are already covered many things about the three-phase induction motors or the induction motor, where we are discussing about the various parameters like the toxic characteristics, construction of the induction machines, operation of the induction machine, and other parameter how we have to construct the induction machines in the previous lectures. Now we are discussing about the power flow in an induction motor. Over here, we are finding that there will be the normally there will be the two parts of the machine. One is the stator part, and second one is the rotor part. So whenever we have to just deliver the supply to the three-phase induction motor, then automatically there will be a stator part will be involved, and from the stator side, that supply will be called as the stator input. Now, whenever we deliver the supply, it will give you the iron losses which will occur in the conductors of the stator winding. Some core losses will be there because whenever the supply is moving over that part, some some iron part will be associated with the machine. So iron losses will be associated over there, and these all losses will be indicated as a stator losses. Stator losses are the important parameter because after giving the supply to the machine, these losses will be associated with the motor. So whenever then the rest power will be delivered to the rotor side. So there is some stator output air gap power is there because in between the stator and the rotor there will be the air gap, and some air gap losses will be there because whatever flux will be produced in the stator side it never linked with the rotor side. So it will be there will be some losses are there, and that losses will be including because all the flux is not linked with the rotor. So some air gap losses will be there. So some air gap power loss will be associated with this one, and the rest power that will be in, given to the rotor side. So some iron losses which will associated with the rotor side is also because there is a core is there where the winding is placed. Either we are looking over a slip-ring type or we are looking over a squirrel cage type induction motor. So some losses are associated with the motor. So that losses will be associated over here. So that losses which will be associated with the core part of the rotor is called the core losses, and the losses which will be associated with the winding of the motor, it will be called as the I square R loss of the rotor. So after reducing the I square R loss in the rotor, then the total mechanical power developed will be given to the rotor to the shaft of the rotor side. So, but before moving toward the useful power output obtained at rotor shaft, some losses will be associated over there, which we cannot avoid because it will be there. So rotor core loss is there, friction losses as the rotor are rotating within a air gap, so some losses will be there. So from friction, it will be arises between the air and the rotor part. So some friction losses are associated over there. Then there will be some windage losses. Windage losses are the losses which will be associated with the some parts of the motor because as there is a fasteners are there, there will be the winding with insulations are there. So some losses will be associated with this one because whatever flux will be produced in the stator never linked with the rotor part. So whatever small component which we are associated over there, that component also develops some losses, and it will block the rotation, it will block the flow of the flux from the stator side towards the rotor side, and some stray losses are associated over here. Stray losses again, these are the losses which will be stay within the winding and never move away from, never moving given the facility to give to the rotation of the stator side. So these losses are given, and after that we are moving towards the useful power output obtained at the rotor shaft. So this is the power flow diagram over there, and it will be indicated in the form of a figure. Now and there will be the input power which will be supplied from the rotor from the stator side. So there is a stator copper losses. It will be the 3 times because we are using the 3 windings. So 3 times of the stator copper losses are there. And then after reducing this one, we are getting the iron losses are there. So iron losses again, there is a 3 types of winding are there. Either we are looking over the squirrel case type or the wound rotor type, there will the losses will be the 3 times of that one. Then we are getting the air gap. That will be the in between of the stator and the rotor. So some air gap losses will be associated over there. So some air gap power will be given and some losses will be developed over that side. So after whenever the supply is moving from the stator towards the rotor, then there will be the all the losses which will be associated over this part is called the rotor losses. So there will be the rotor copper losses are there. So whenever the winding is there, so obviously the 3 windings are there which may be associated with the individual phases. So the rotor copper losses will be the 3 times, and then there is a ventilation and the friction losses which we already called over there as a stray losses. So there are some different names will be associated over there, and all other losses except the rotor copper losses, we all the losses we are including in the ventilation and the friction losses. So some books will be given the different types of names are there. So these are the another name of the ventilation or the friction losses are there. Then there is a power rotor which will be indicated by this one. PD equal to 3 times of I square RT into 1 minus S upon S. So it will be also associated with the slip. So as the slip is high, then the losses will be different. If the slip is low, then obviously the losses will be different. So whatever differences will be we are getting from that side, after deducting all these losses, we are getting the output power which will available at the shaft of the motor, and it will give you the rotation. It will develop a torque at the rotor side. This will be the another method through which we can identify about the numerical parameters, how we have to find out that which parameter is given to us and how we have to calculate the output power for a machine. Previous one will be the graphical representation over there. Now we are getting the actual notation of the machine and how we have to just calculate the losses and what are the different losses we have to just deduct it and find how we are finding out the output power. So over here we have the three-phase AC source, which will be given the three-phase supply, and it will be indicated by the PI as the input power which will be delivered to the stator winding of the machine. Then there will be the losses, stator copper losses and the stator core losses are given. After deducting these losses from the input, we are getting the PG. PG stands for the air gap losses. So air gap losses will be given after reducing this. We are getting the rotor copper loss. Then we are getting the mechanical power developed that will be indicated by the PM. So there is a some standard notations are there. PI stands for the input power. PG stands for the air gap power, PM stands for the mechanical power developed, and after that we are getting the at the shaft. Just at the end of the shaft we have the losses like the friction losses, windage losses, stray losses are there. Then we are getting the output power PO. PO stands for the output power of the system. So this is the concept regarding the power flow diagram of the machine, that how the power will be delivered from the input side and how it will be reaches to the output side, and how all the losses will be indicated over there, and what are the parameter we are getting at the end of the stator, means whatever is the output of the stator, that is the input of the air gap, and after the end of the air gap we are getting the input as the input to the rotor part, and on the shaft whatever is the output we are getting from the rotor end, we are getting the output power at the shaft. So this is the power flow of the three-phase induction motor. Thank you.